to you like this, or from a graph that you draw yourselves. So it says use the graph to answer the given questions. Yesterday we talked about using the graph to evaluate the function, like the f of whatever, finding domain and range, finding the values where it equals 0, the intervals for its increasing and decreasing, and the max and min values. So when I look at this graph and I want to find f of 2, what would be the answer? 4. Good. So you're going to go to where your x is 2, and you're going to give the y coordinate that matches it, which in this case would be 4. Okay, domain and range. So domain is left to right. And if this graph is cut off like this, what's implied here? Good. Like it's going to keep going. There's going to be arrows. Let's see if it'll catch up. All right. So again, if our graph gets cut off at the end, we assume that there are arrows there. So the x values are going to get smaller. Even though this is pointing up, it's pointing up and left, right? So the x values are going to keep getting smaller, which means my domain is going to start at negative infinity. And these values, although they're pointing down, are also pointing to the right. So the x values are going to continue on forever and going to positive infinity. How about your range? What's true about those arrows? Remember, range is bottom to top. Continues on till negative infinity, right? And it points up, continues on to positive infinity, okay? So if one of these had stopped, like let's say this stopped here and none of this was here, how would that have affected my domain? It'd go negative 1-ish, right, to positive infinity, right? How would it affect my range? Good. Negative infinity to 6. Everybody understand? Okay. All right. Then came the question, find the values of x for which f of x equals 0. F of x is the same thing as what? Y. So we're saying where's y 0, what else is that called? It's called, these would be x-intercepts, right? These would also be zeros. These would all be roots, like all those names, okay? So how many times does it happen? Twice. The first time f of x is 0 would be when x is 0. And the second time is 3. When you list, so this time we don't put it in coordinate point form because it's not asking for x-intercepts. If it said x-intercepts, coordinate point form, if it's asking for the values of x for which f of x equals 0, then it's just 0 and 3. All right, number 4 says state which intervals the graph is increasing or decreasing. I'm actually going to skip to 5 because this is going to help me answer this question, right? Every time I have a max or a min is when my increasing and decreasing behavior is going to change. So I have a relative minimum here at 0, 0. I have a relative maximum here at 2, 4. So that tells me that from the end of my graph, which is negative infinity, up to this x value, so up to 0, my graph is falling as I move from left to right. So that is, well, let me do my relative max was 2, 4. My relative min was 0, 0. But that first pass is falling as I move from left to right, so it is decreasing from negative infinity to 0. That's that section of your graph. Then it changes direction and it comes up. And so as it's rising as I move from left to right, I would say that's increasing from 0 to 2. I always do the x values. So it is increasing from 0 to 2. And then it changes direction at that relative max. And it comes back down again. So that would be decreasing. I'm going to put the U. And it would be from 2 to positive infinity. Yeah.
Do we not use brackets for...
Good question. No. Think about, like, can a point be increasing? Right? You're saying the only exception is if your graph starts or stops constant. So like if I had a line that looked like this to start my graph. Son of a biscuit. Okay. If this wasn't here, let's say it started here, this is the only time you're going to see a bracket. When your graph starts at the very beginning with a solid dot and it's constant, or it ends like over here, if it ended here with a solid dot. That's the only exception to the increasing and decreasing parentheses. So when in doubt, put a parentheses because it happens way more often than not, okay? Same thing on an infinity, like you'll never get a bracket on an infinity because you can't have an infinity value. So increasing and decreasing, always parentheses. The only time it changes is if it start or stop constant. Like there's nothing at the beginning except for a solid dot and it's horizontal, and there's nothing at the end except for a solid dot and it's horizontal. That's the only time. Even at this point where it changes direction, that is not constant, so it doesn't have a bracket. It would have a parentheses. Questions on any of that? Because it kind of wrapped up what we did yesterday, or what you should have done yesterday. Okay, so let's jump back to the notes. We're gonna save this this slide for tomorrow. So this is what we talked about yesterday: domain and range, indicator values, the graphing utility, vertical line test, zeros, increasing, decreasing, max and min, and you should have gotten to there. So I'm on example 5, and it says find the zeros of the function algebraically. Then use a graphing calculator to graph. Then identify the relative max and min and the increasing, decreasing behavior. So how do I find the zeros algebraically? Good. I'm going to set it equal to 0. And then solve however I got to solve, but this time we're factoring. What can I take out on the right-hand side? God bless you. I can take out an x, I can take out a negative x or an x, it doesn't matter, okay? What you cannot do, and a common mistake, is now divide both sides by x, because that means you just eliminated a 0, okay? You cannot cancel out by dividing by x. So instead we split and solve. So when I split and solve here, I get x equals 0, so that's one spot it's going to cross the x-axis. And then I would solve the other side. Negative 9 equals 2x, and x equals negative 9 over 2, which is negative 4.5. All right, so I typed in the equation. This is one that has a leading negative, so you got to make sure you don't use your minus sign. You use your negative sign, okay, or it will give you an error. And then I graphed it. This is like whatever the window was set to the last time. So my standard window should look like this. All right, so it says use the graphing utility to graph and then identify the relative max and min and the increasing, decreasing behavior. While we're on it, let's check and see if our answer's right for our zeros. We expected it to cross the x-axis twice. It did. So then I'm going to go second, trace. I'm going to go to 0. It brought me right to the one that's 0, 0. So I could go left of it and then right of it and then hit enter, but it's going to take you back there. And then I'm going to do it again. Second, trace, go to 0. I'm going left of the other one, right of the other one, and hit 0. I'm going to hit guess, sorry. And there's my negative 4.5. So we were right, and that's how we can check it. Okay, now I need to be able to find my max and min so that I can figure out my increasing and decreasing behavior. The max is getting cut off at the top there, okay? So I could either, remember I could zoom out, I could hit zoom, zoom out, and hit enter again. Or I just need a little bit of space on the y's. So I could go to my window and I could go to my y max and literally like change it to like 15. Probably could have done 12. But I just need a little bit of space on the top. Now to find your max, I go back to the same menu. Second, trace, and I'm going to maximum. And it asks the same questions as the zeros did. Left bound, right bound, guess. So I got to go left of my max. I'm going to hit enter. I have to go right of my max. Hit enter. And then guess and hit enter again. And that maximum value, so the coordinate point there, is negative 2.250 and 10.125. You with me so far? Okay, if my graph had like gone down and come back up again and I wanted to find another max, then I do the same thing. Second, trace, maximum, left of that one, right of that one, guess. Okay, and if I wanted to find the min here, then I would do second, trace, minimum, left, right, enter, and it will bring you to that one. So for as many max and mins you've got on your graph, that's how many times you'll have to find them. For this one, there's just that one. So then I want to find my increasing and decreasing behavior. My arrow points to the left here and it comes up to the max. So it is increasing from negative infinity to the x value on the max, which is negative 2.250. I don't need the 0, but it's there. And then it changes to be decreasing. God bless you. So it is decreasing from negative 2.250 to positive infinity. Questions on those? Yeah. There is none because the arrows both point down. So I needed to come down and come back up again to create a minimum. Yep. So on your test, you're going to get one big chunk of a question that says use a graphing utility to graph this, and then find domain, find range, find intercepts, find zeros, or it'll say intercepts or zeros. Find increasing and decreasing behavior, max and min. If it's none, you literally just write none. Any questions before we move on? Okay. All right, so now we're going to talk about graphing piecewise functions, okay? And these we will graph by hand. So a piecewise function, if you remember from last week, are functions that have multiple parts, like conditional parts. So in this case, it's saying f of x is 2x plus 3 if x is less than 0. And f of x is 3 minus x if x is greater than or equal to 0. I'm going to show you two ways to do these. And to be honest, I use a blend of this pattern. If they are both lines, then I tend to do it the way I'm going to show you the first way. And then if it's a mixture of maybe a line and a parabola, or a line and a square root or something like that, then I will change and I'll use the second approach. But you get to choose what you want to use, okay? So the first approach is literally graph these as though they are two separate things. So the first one I'm going to graph is f of x equals 2x plus 3, which is a line. The y-intercept is 3, so I go up to 3 and I put my y-intercept. And my slope is 2, which is 2 over 1. So I go up 2 to the right 1 or down 2 to the left 1. And I draw the line. So I graph it in its entirety. And then I look at the restriction. When do I want this graph to be drawn for? What values of x? Just less than 0. Not less than or equal to, right? So less than on a graph looks like what? Solid dot or open dot? Open dot. So I'm going to start at this open dot here because that's where x is 0. And I want it to be less than it, so I only keep this part of my graph. And I would physically erase the other side. Then I'm going to graph the other side, which is f of x equals 3 minus x. Still a line. Y-intercept still at 3. This time my slope is negative 1, so I go to the down 1 to the right 1, or up 1 and to the left 1. And my full graph line would be this. But these values I want to keep for when x is what? Greater than or equal to 0. So I'm going to erase all the stuff that comes before it. Greater than or equal to actually means I get a solid dot. So the solid dot from the second one overtakes the open dot from the first one, which is fine. And my piecewise function would look like this. Now piecewise functions are still functions, right? So if I had kept the other side of that orange line, it would have failed my vertical line test, right? It can't fail your vertical line test because then it's not a function. You with me? Okay. So your other option, and I won't do it on this one, but I'll show you on the other one. My other option is, maybe I don't know what this graph looks like exactly. Well, I could plug in these points. I could start at 0 and then work my way left. So I would plug in 0. It would be an open dot. I'd plug in -1, -2. Plot those points, draw the graph. Then I'd come here. I'd plug in 0, +1, +2, and I plot those, and I draw that side of the graph. Okay? So you can either graph the whole thing, erase what you don't want to keep, or you can plot the points that are specific to the range that you're given. Just be careful because you have to include this one, even though it's not or equal to, in order to figure out what it's an open dot there. But in order to know that open dot, where it goes, I have to plug that point in. All right, so let's do that one. Example, what am I on? 6, okay? I'm going to say, because the top one is a line, I'm going to do the top one the way we just did it, and the bottom one's a parabola, I'm going to plug in some points, okay? So you can see both. So the top one is a graph line where my y-intercept is at 1, and my slope is 2, up 2 to the right 1, or down 2 to the left 1, but I only want it where x is less than or equal to -1. So my graph would have looked like this, but I only want it where it's less than or equal to -1. So I'm going to erase all of that and only keep where it's less than or equal to, so solid dot, -1, and then everything below it. With me so far? All right, for the bottom one, I know it's a parabola. I could kind of approximate what it looks like, but I need to know those exact points, so I could just plug them in. So I'm going to start where x is greater than -1. So I'm actually going to start where it is -1. And then I want it to be greater than it, so I'm going to plug in like 0 and 1. So I get -1 squared minus 2, 1 minus 2, which is -1. 0 squared minus 2, 0 minus 2, -2. And 1 squared minus 2, 1 minus 2, -1. And I'm going to plot these points at -1, -1, it's an open dot. At 0, -2, it's a solid dot. And at 1, -1, it's a solid dot, and it's got a parabola shape. So I would know eventually it would come up. I don't need this part to be perfect, okay? You could plug in extra points if you really wanted to. But you do know at least it's a parabola, so it's going to come back up. And this, the orange solid dot overtakes this open dot. So technically that's still a solid dot. So if you saw a graph and it was like a multiple choice and one had an open dot there and one had a solid dot there, the solid dot's what you're looking for. Questions? Still good? All right. Last thing in this section, well, one more thing after this, sorry, is even and odd. Okay? So even and odd functions are, Alec, stay with us. Okay, are functions that if it's even, it means it has symmetry to the y-axis. And if it's odd, it has symmetry to the origin. Now these are functions, so they can never be symmetric to the x-axis. That's why that's not part of this. Even, y, odd, origin, okay? There's no such thing as a function with symmetry to the x-axis because it would fail your vertical line test. And this notation to me is confusing. It goes back to the same rules you had on your y-axis symmetry. I'm going to take x, replace it with -x, and this time what we expect to have is it go back to the original. Not all of them are going to change because we don't have a y, we only have an f of x. So change x to -x, and it should go back to the original. Think about what makes x go back to positive x. What kinds of things are you looking for in an equation? If it's squared, what else? Sorry? Multiply by a, yeah, so what would be if it was negative and a negative? Yeah, what else? Absolute value. So if I had x squared plus 4, that's going to be symmetric to the y-axis, which means it's even. If I had absolute value of x plus 1 or whatever outside the absolute value, then it's going to be symmetric to the y-axis, which means it's even. Okay, so for the odd, it is a little bit different because we're not expecting it to go back to the original, okay? We're expecting the signs to change. So we change the x to the negative x. If there was a y, I would change the y to negative y too, but there is no y. So what we do expect is all signs change. Okay? Not including the f of x though. Because we don't plug anything in for f of x. So an example of this is f of x equals x to the third. This time, if I plug in a negative x there, what happens when I raise it to the third? Does the negative go away? No. So this becomes f of x equals negative x to the third. So you could choose, like you could fall back on your origin test. You could change that f of x to a y. You could plug it in, okay? And you could see if all the signs change. Or you can ignore the f of x and you could just see if the other side changes. It's the same test, okay? The difference is that these are functions, so you don't have a y in them initially. So even y-axis, odd origin. Still good? All right. If you're looking at a graph, even y-axis, odd origin. So again, like a parabola that's on the axis, or an absolute value that's on the axis, and then origin, like an x to the third function, where whatever happens in the top right flips down to the bottom left, or vice versa here. All right, last question says, graph the function. Determine if the function is even or odd, and the intervals for which f of x is greater than or equal to 0. And then it says, use a graphing utility to verify. So we're going to save that for the end. We're going to graph this by hand. I will tell you that we'll get better at these tomorrow because tomorrow we do transformations. But let's just say we don't, okay? We know that this is what kind of a graph? It's a parabola. What else do you remember about it? What's a negative on the front do? Like on the front of the x squared. Flips it upside down, okay? What's the 4 by itself do? Do you remember? Shifts it up, okay? If we know none of that, we're plugging in points, okay? But because you know some of that stuff already and we will review it again tomorrow, we could save ourselves from work. So knowing that at least I go up to 4 and I point it down. That's an approximation of my graph. Now it says, is this function even or odd? If I'm looking at my graph, what would you say? It's even because it has symmetry to the y-axis. If I'm looking at my equation, I would have plugged in a negative x, and it would go back to the original function, so it confirms it, okay? So this is even, it's an even function, okay? Now for the second part, it says find the intervals for which f of x is greater than or equal to 0. F of x represents what? Y. On a graph, how would you know where y's are greater than 0? Hit the x-axis and above, right? If it just said greater than, I wouldn't include those points. If it says greater than or equal to, I actually have to know where it's going to hit the x-axis, okay? How do I know when something's going to hit the x-axis? I want to find where y is 0, yeah? So I'm going to set my equation equal to 0. I get x squared equals 4, and x equals plus and minus the square root of 4. So x equals plus and minus 2. So our initial graph was an approximation. A more accurate one has it passing through the zeros. All right, so I found my zeros, which gives me these two spots, okay? Now the question says, what's the interval for which f of x is greater than or equal to 0? So I'm looking for everywhere above the x-axis, where it hits the x-axis or where it goes above the x-axis, okay? On the interval of this graph, that means it's literally from this dot all the way to this dot. wait for it, okay? It's from here all the way to here. So how do I describe any kind of interval like that? I'm going to use the x values. So I would say my graph is greater than or equal to 0 from -2 to +2 with a bracket on each. If it had said greater than and not greater than or equal to, these would now be parentheses, okay? But because it says or equal to, I am including all the x values from -2, God bless you, to +2. Questions? So if I had put this on my graphic utility, I would have gotten this graph, okay? I would have found this 0, and obviously that's between them is where it would be greater than or equal to. Let's say I had asked you for where f of x is less than or equal to 0. Now I'm talking what part of my y values? What part of the graph would be less than? Under the x-axis. So that answer would be from -infinity to -2, and then from 2 to +infinity.